Today we will be doing that is experiments on electrolysis. Electrolysis, that means you will be passing electric current through an electrolyte and it will dissociate into its ions. That is called as electrolysis. Alright, you will be taking an electrolyte. Basically it's a strong electrolyte, we will be taking it, and when you pass electric current through it, then you will see it dissociates into its ions. That is called as electrolysis. You know it. Now let us see some examples here. For example, suppose if I take that is molten sodium chloride. What I said? Molten or fused NaCl if I take it. So it contains only two types of ions. What is that? Na plus and Cl minus. Cations and anions you can see. It is a fused sodium chloride I have taken it. Now at cathode what will happen? At cathode that is Na plus E minus will give you what? Na. Alright, we got sodium at the cathode. Now at anode, cathode is negatively charged, you can see that, and anode is positively charged. Alright, now it is electrolysis, students. It is not what you can say electrolytic, electrochemical reactions. It is electrolysis. So in case of electrochemical reaction, that is electrolytic cells, you have seen it there, that is a galvanic cell. The cathode was positive and the anode was negative. Alright, here the cathode is negative and the anode is positive because both the principles are different. In electrochemical cell I have said in the beginning, that is chemical energy is converted into electrical energy, and in electrolytic cell, that is an electrolysis, electrical energy is converted into chemical energy. That is, we are dissociating the chemical energy into what you can say, we are dissociating the electrolyte into its ions. We can say that. Clear? The principle is different in both the cases. At anode, what will happen? Cl minus E minus, it will give Cl. Now Cl does not exist because atomic state does not exist. So hence it will react with another Cl to form Cl2 gas. So what you will find is that the observations, because basically here the important is observation. Here we don't see any observations. Here we will see the observation is that a greenish yellow colored gas is evolved from the anode. Listen carefully. A greenish yellow colored gas is evolved from the anode. Now one more thing you should know it, that here the two changes are taking place when an electrolysis takes place. One is the primary change, another is the secondary change. Primary change means the conversion of ions into its neutral particles. That is called primary change. This is known as primary. This is known as primary. Again I repeat, the conversion of ions into its neutral particles, that is called as a primary change. So this is a primary change. This one is a primary change. Now secondary change means if suppose a neutral particles you are getting it is obtained as it is. Alright, it is obtained as it is. Like in case of sodium, it is obtained as it is. No problem. But in case of chlorine, we are not obtaining as it is. It combines with another chlorine atom to form chlorine molecule or chlorine gas. So hence this change is called as a secondary change. Alright, again I repeat, the conversion of ions into neutral particles is called as a primary change. If you are obtaining the product as it is, as in the case of sodium, I am obtaining the product as it is. By the primary change only I am obtaining it. But if you are not obtaining the product as it is still further simplified. Alright, then it is known as a secondary change. As you can see in case of chlorine, it is not obtained as it is because chlorine atom is not stable. So it further combines with another chlorine atom to form a chlorine molecule. So this is called as a secondary change. In this way we are having two change when electrolysis takes place. One is the primary change, another is the secondary change. So you got these reactions when fused sodium chloride undergoes electrolysis. We can say that. Next, after that we will see that is electrolysis of dilute sulfuric acid, or we can say acidulated water. Electrolysis of acidulated water or dilute sulfuric acid. Achha. To perform this particular electrolysis, we use a Hofmann's voltameter. Hofmann's voltameter, not voltmeter, voltameter. Voltmeter is used to record the potential difference. Voltameter is an apparatus used to do the experiments on electrolysis. Basically, we take acidulated water and we do the experiments on electrolysis. Got it? The voltameter, it's more or less it is this sort of, not exactly I am drawing it here, not exactly the same thing, but more or less I am drawing the figure which will help you to understand it. Alright, so it is more or less this sort of the figure is this sort of, we can see. One it acts as a cathode, another is acts as a anode. From here we are adding the water, that is acylated water. And one is a cathode and anode. In one case oxygen is collected, in another case hydrogen gas is being collected. This sort of voltameter and apparatus. We are having a stopcock here. Stopcock is there to open and close it. We can say that here also same thing we are having it. Okay, so this sort of apparatus we are having it here, and we are having the electrodes which is connected to a battery. Got it? When the current flows through it, then water dissociates into its ions and hydrogen and oxygen gas is collected at the respective electrodes. We can say that. Clear? Acha. So we are not interested in the apparatus now, basically, because nobody is going to ask you the apparatus, but you should know the name of the apparatus. For that reason I said you the name, which is Hofmann's voltameter. Okay, fine. Now, when you are doing the electrolysis on acidulated water. Now, why do we take acidulated water? You know very well that pure water is a bad conductor of electricity. When we add acid to the water, which acid? Dilute sulfuric acid, a non-volatile acid. When we add it to the water, then water becomes conducting. And hence it dissociates into its ions. We can say that. Clear now? So, hence what we will be taking it here, that is HOH. Water dissociates to give you H plus OH minus. As we are adding sulfuric acid to it, it will also dissociate to give you H plus and SO4 2 minus. You will be getting it. Now here we are having two cations. Of course the two cations are of similar, that is H plus, and two anions. One is OH minus, another is SO4 2 minus. Now what will happen? Now see here, add cathode, which will go to the cathode. Now we are having an electrochemical series here. Electrochemical series. According to the electrochemical series, the ions which are placed at the bottom of the series gets the first preference to get deposited at the respective electrodes. ICC students, they have studied in class 10 about electrolysis. They knew about the electrochemical series. Alright, what I said you? According to the electrochemical series, the ions which are placed at the bottom of the series get the first preference to get deposited at the respective electrode. Even you have also studied electrochemical series just now. We have finished electrochemical series. Alright, you have studied there. So you will see that the ions which are placed at the bottom of the series, alright, gets the first preference because they are having higher reduction potential. So hence they get the first preference to get deposited at the respective electrode. We can say that. Remember it. They get the first preference to get deposited at the respective electrode. Clear? Acha. So at cathode, what will happen is that here both the ions are same, so no problem. H plus ions will go to the cathode. So H plus will gain one electron to form H. H does not exist because it is an atom. It does not exist in atomic state. We get H2 molecule at the cathode. Now at anode, what will happen? Now here you have to understand it. Electrochemical series. According to electrochemical series, you will find is that OH minus is placed at the bottom of the series. Bottom of the series, OH minus is being placed. Now, as OH minus is being placed at the bottom of the series, compared to SO4 2 minus, understood? Compared to this, alright, SO4 2 minus, it is being placed at the bottom of the series. So OH gets the first preference to get deposited at the respective electrode. Alright, OH gets the first preference to get deposited. So hence, OH minus E minus will give you OH. Neutral OH, you get it. Alright, now for OH, this sort of will decompose to give you two molecules of water and oxygen gas is released. How do we know oxygen gas and hydrogen gas is released? Very simple experiment. Hydrogen gas, that is if you bring a burning splinter near to that, one of the electrode, alright, of the Hofmann's voltameter, you will find the burning splinter goes off with a pop sound, proving that the Hofmann's voltameter, that particular electrode contains hydrogen. Alright, and another electrode, if you bring it near to it, you will find it out that it glows brightly. The burning splinter glows brightly, proving that that particular limb of that particular electrode contains oxygen gas, because oxygen helps in burning. So the burning splinter glows brightly. Not only that, you will find the volume of hydrogen to oxygen which is being collected in the ratio of nothing but it is 2:1. 2:1. Hydrogen is to oxygen, the ratio in which it is being collected is 2:1 because H2O, isn't it? So what is the ratio of hydrogen to oxygen? 2 volumes of hydrogen combines with 1 volume of oxygen to form 1 volume of water, isn't it? So hence what you find is that the hydrogen to oxygen, the ratio in which it is collected, the volume, you can see in Hofmann's voltameter that 2 volumes of hydrogen is collected compared to 1 volume of oxygen. We can see it also. Got it? Clear? Now you will say that how will you see, sir? Both are what you can say, this gases are not colored gas. There is the colorless gases. How do you come to know? The level of the water which is being collected. The level of water which rises in the limb, you will see that. Got it? The level of water which rises in the limb. If you see the level of the water, you will see that the level of the water which rises in oxygen is twice that is in hydrogen. That means above oxygen the gas is collected. Above oxygen, above that water the gas is collected is oxygen. Listen carefully. The level of water which is collected in oxygen is twice than that of hydrogen. Why? Because the volume of the gas collected of hydrogen will be twice and the volume of oxygen will be half of that. Alright, volume of oxygen will be half of that. Clear? Listen carefully what I said. Volume, the level of water collected in oxygen is twice that of hydrogen. Why? Because the volume of hydrogen collected, volume of the hydrogen gas collected above water is twice than that of oxygen. Is twice than that of oxygen volume. So hence, for that particular reason, we can come to know, we can see it. Alright? That means if I draw it, if you don't understand, I'll draw it and show it to you. Like this is your, what you can say, oxygen. Let us say oxygen gas is collected. Clear? This is the both are level. You can see both are at the same level. See, both are at the same level now. So oxygen gas is being collected this much. Got it? Or I can say little bit more also. I can take it. Suppose this is oxygen gas is being collected this much. Clear? This is your O2. This is the level of the water. Clear? Hydrogen will be almost double. So the level of the water is here. So this is your hydrogen gas. Now see it. Hydrogen is twice that of oxygen. Alright, this is water. The water is twice that of hydrogen and the hydrogen gas collected is twice that of oxygen. Now I think it's been clear to you, this particular thing. Alright, so you can see in the Hoffman's voltameter. And I said you also how do you test it? You bring it a burning splinter and you will come to know in case of hydrogen it goes off with a pop sound, but in case of oxygen it burns brightly. Got it? Now here you can see this is a primary change, this is secondary change. Again, this is a primary change, this is a secondary change. You can see it. Now the question is here, how to remember the electrochemical series? We are having a poem for that to remember the electrochemical series. Alright, for the positive it's different, for the negative it's different. I have made it. Now for the positive it is, Peter cannot manage all zeal in love, hate, care much sincerely. Peter cannot, two words, manage all zeal in love, hate, care much sincerely. Peter means potassium, can means calcium, not means sodium, manage magnesium. In this way it goes on. All means aluminium, zeal means zinc, in iron, love, lead, hydrogen, that is hate, care means copper, much means mercury, sincerely means silver. Now for the negative I don't have to remember it. Why? Because in negative the first it comes is your sulfate, then fluoride, then chloride, then bromide, then what you can say that is sulfate, then sorry iodide, bromide, chloride, fluoride, and the last is your hydroxide. Very simple. So you don't need to remember the negative one. Negative is very easy to remember. In this way you can see that how the hydrogen oxygen gas is being collected by the electrolysis of acidulated water. Thank you.